Okay folks, just a little new video for you for exploring Newfoundland Railway. This contraption in front of you here is a railway relay that was salvaged from the Bonavista Branchline many years ago, and I've decided today to do some research on this particular relay, and to make a long story short, the relay controlled track signals, such as the flashers on the cross bucks, on the lights on the lights here. It would also lower the arm as well. It could control that. It could control lots of different accessories that could be used on the track. So I just decided today to figure out how to wire the relay up. I mean, I'm quite familiar with relays, yes, but it took me the longest time to try to figure out what voltage these relays operate on. And today I figured out what that voltage was. Now, there's two different versions of these relays, these railway relays. Some of these are AC relays, and some of these are DC relays. This particular unit is a DC, direct current relay. The model number, which is on the plate here, maker's plate, is a Type K DC relay, catalog number A65-311. Is made by General Railway. Hard to see what that says there. General Railway. Looks like Signal Company, Rochester, New York. There we go. It's a interesting one. The serial number is E125414, made in the United States. Still has its sticker on the inside. It's tested by the date it was tested was March 31st or March 11th, 1971. So yeah, long time ago. But today I figured out what voltage it runs on, and it's fairly low voltage. The relays actually run on 6 volts. Well, it can run as low as 6 volts, and between 6 and 8 volts. But it's a 6.5 volt relay. That's direct current. So basically what we have here, we have 6 contacts on top and 6 on the bottom for a total of 12 connections. You can see that each block can be controlled by 6 different 6 different connections. So you put your voltage in on 1H or 2H, and depending if the relay opens or closes dictates on which circuit here that you attach to. And this here is on this side here, 4H, 3H is the same thing on this side as it is on this side. So basically what I have done, I have my voltage, my 6 volts, run in on 4H, and I have it coming out on 4D or B. I think it's B. Anyway, so coming out on 4H, going out on 4B, and then it goes out to my little test circuit with the 2 flashing LEDs, and that's supplied by 12 volts. So basically what I've got is 12 volts in on the circuit here. So you got 6 contacts here, corresponds to 6 contacts here. This configuration the same as right here, and for a total of 12 positions that you can possibly put your circuits on, depending on what you want to switch in or switch out as to what the relay is doing. So I have my 12 volts, as you can see, coming in here, and that would be 4H. I have my DC output to my circuit on this bolt, which is 4B, and that goes out to the crossbuck. As you can see, 12 volts in from the power supply. So 12 volts in. I have my negative. Don't mind that there. I just got that holding the wire down, but I got my negative connected directly to the circuit, and the only thing that's breaking the circuit from this working is the contact between 4H and 4B, which is right here. So I'm gonna demonstrate how the relay works in relation to how 4F and 4B is wired up. So for demonstration purposes, right now I'm wired up to 4B, which is 4B and 4H was the top two contacts, and I'm controlling the circuit with just a on-off switch, just a momentary switch. This would actually be the contacts, or I should say the wheel set on the actual equipment rolling over the track would cause the circuit to work, which is pretty cool how it was set up. But this is a Newfoundland Railway relay. It was used on the Bonavista Peninsula, Bonavista Branchline. But I'm going to hit the momentary switch, and you're going to see the contacts change. I'm going to press in, opens the circuit. As you can see. Now, I'll just put demonstration purpose over here. So now we're going to hit the same switch again, and you're going to see the lights come on. There we have it. Cool, isn't it? Okay, for demonstration purposes once again, this time I have my ohm meter hooked up to the opposite side of the relay. I still have my crossbox set up to this side of the relay. So using the same sets, which would be, again, I'm using 4H, 4B, and I'm using 1H and 1B for this circuit. So what's going to happen, just to demonstrate how it works, when I press my switch, the crossbox is going to start lighting, and the meter, you're going to hear a buzz from, a tone from it. So, I'm not going to get two of these coming at the same time, but let's give it a try. There you have it. Now, so now you may ask yourself, okay, so what if you take the wire from here and transfer it to here? So effectively what you're doing is taking the circuit from 4H and moving it to 4F versus 4B. So basically what's going to happen here is when the relay is not energized, 4F will be in line, will be in circuit with 4F or 4H. So let's just switch it in there, and you'll see. when the relay, when I'm not pressing this, the light will stay lit. So let's just move it from this position, and we'll move it to this position. Now you'll see that the crossbox is lighting up, but you're not hearing a buzz from the meter. Now, just watch what's going to happen. Wait, when I press this button, this switch, what do you think is going to happen here? What's going to happen when I press this momentary switch, when I push in on it, the crossbuck lights are going to turn off. They're going to turn off, and then you're going to hear a tone from the meter when I push in on this switch. So just watch. There you have it. It's actually controlling two sets of circuits. Right now I'm controlling two different circuits. One side of the relay is controlling the meter, the other side of the relay is controlling the lights. So that gives you an idea of how the system, how this relay operates. It's a very cool setup, I have to say. Okay, so for this demonstration, we're just going to forget about the 6 contacts on this side of the relay. We're just going to concentrate on the 6 on this side. So right now we'll be working on 3H and 4H, and 4B and 3B. So 4H, connected to 4H, we're connected to 3H, we're connected to 4B, and we're connected to 3B. Okay, so we've got power connected through 4H, and it's going out on 4B. We've got my meter hooked up to 3H, and it's going to 3B. So right now, you would notice that in the contact position, that this contact here would normally be closed, or usually be in contact with 4H, or 4F. Contact here, 4F. It's only when I close the contact via the switch, the contact moves from here and connects to the circuit to make the voltage flow from 4H to 4B. And vice versa, the same thing with 3H to 3B. 4H goes through to 4B, 3H goes through to 3B. So let's just demonstrate that's what's going to happen there. So right now, as you can see, wires are connected. I've got the crossbuck lights, and I got my meter. I've got the switch here. Now we're going to hit the switch. The meter is going to buzz, and the lights are going to come on. How cool is that? Okay, so again, for demonstration purposes here, we have the 2 wires changed. So now we're connected to 4H right here, and we're connected to 4F. Now remember, 4H and 4F are always connected unless the relay is energized. So when 4H and the other wire is connected to 4F, crossbuck stay lit. So when I hit the switch, relay energizes, lights turn off. So there we have it for that demonstration. Okay, so now we're connected to 3H, through this bolt, and we're connected to 3F through this bolt, or contact, whatever you want to call it. So 3H now goes to 3F, and you'll notice that cross bucks are still on until I hit the switch over here once again, and the lights turned off. Okay, for this next demonstration, we have our power input is now going on to 3H, and the output is now going on 3B. So what will happen here is the exact same thing that would happen when I was on 4H and 4B. Now I'm on 3H and on 3B. So I'm connected to this bolt and this bolt back here. You notice that the light is not on. So now when I hit the switch over here, cross bucks will turn back on. Cool stuff, don't you think? So yeah, so if anybody, just watching the channel has never seen these relays in operation, well, you just have. And again, this relay is catalog number A65-311. It's a 6.5 volt relay, low voltage. So yeah, this is very cool how these worked. You have a combination of 12 contacts to play with. So there's a lot of circuits you could make work here. You can run off one relay. You can only imagine how many circuits you can control just by one relay. So now if you've got a relay box and it has 6 or 7 of these relays, well, you only imagine how much circuits are being controlled in these relay boxes by individual relays. And that these relays can get pretty big. They can get a lot more contacts on them. They can get a lot less contacts on them. Depends on how they're planning on utilizing them. But it's pretty cool. If you're wondering what the power is on this one, I have, now whereas a relay, it's a coil. It doesn't really matter per se how it hooks up. But I have my negative on this contact here, and I have my positive over here from my power supply, which is a different circuit again, different supply. So I'm going to turn on my light. There we go. That's the power supply I have controlling it right now. I could put it on amps. So this energized the coil. The coil is actually energized when it's in its relaxed state. As you can see, there's amperage. Just an indication of amperage, but that's about 1 amp roughly. So the relay uses 1 amp voltage in its closed, or I should say, when in its closed state. In its normal state, it uses up 1 amp of current until it turns on. It does that. So in theory, to keep the relay from drawing this much current, you could utilize another relay control the current. One relay basically turns on another relay, if that makes sense. But anyways, hope you enjoyed this little demonstration of a Newfoundland Railway signal relay. Newfoundland Railway signal relay. It's a tongue twister. Say that one 10 times over. Anyways, hope you enjoyed the video, folks. All the best. And we'll see you on the tracks out there sooner or later. All the best.